Ready for chapter 8? Well, ready or not, here it comes. Sorry about that. So, monomials, mono means one. So, monomial means it's one single term. Polynomial means it's more than one term. If it helps you think about what the prefixes are helping us know, like Christians are monotheistic. Theist or theistic is referring to God. Mono means we believe in one God. There are other religions, especially some Eastern religions, that believe in more than one God, or like Greek mythology and Roman mythology was polytheistic. Poly means multiple. They believed in more than one God. But we're talking about math, not theology at the moment, or religion. So here I nearly wrote polytheistic. That's great. So a polynomial. It's a monomial or a sum of monomials. Now, the sum can mean subtraction as well, because you can always view subtraction as adding a negative number. So it's not saying only addition's allowed. It's just talking about adding or subtracting. Now, one thing you need to know is they cannot have a variable in the denominator. That goes into another category of things that we're not dealing with right now. So no variables in the denominator or in the exponent, which we've not seen very much of that anyway, but just wait for Algebra 2. So if there's just one term, we call it a monomial. If there's two terms, we call it a binomial. Again, thinking about what the word is saying, bi, just like bicycle. A bicycle has two wheels, binomial has two terms. And just like a tricycle has three wheels, a trinomial has three terms. So all of these, including monomials, are called polynomials. Polynomials is the overlapping umbrella that covers all of them. When there's one, it can also be called a monomial. Two, it can also be called a binomial. Three, it can be called a trinomial. After that, we just say it's a polynomial. Now, another word we want to know about polynomials is their degree. Now, all polynomials have a degree, no matter if they have one term or 11 terms. They still have a degree. And it's their highest degree or highest exponent overall. So the degree of any constant, meaning a number without a variable, will be 0. So if there's a number all by itself, its degree is 0, because it has no variable. So its variable is raised to the 0 power because it's not there. But anything else is pretty obvious. Like any variable, it doesn't matter if it's x or y or a or b or whatever. You just look at the exponent, and the biggest exponent you see, that's the degree. So let's practice that right now. So 5x squared, we're just looking at that all by itself. Monomial, one term. So 5x squared, well, the exponent is 2, so the degree is 2. 42. That has no exponent. It's a constant. So the degree of a constant is always 0. Now, when we have more than one term, we do have more than one power. Like this has a power of 0 as far as the exponent. Now, this is 5 to the first power. We're not concerned with the powers of the numbers. We're concerned with the powers of the exponents. So this one has a power of 0 because there is no exponent. This one has a power of 2. And as it says, the degree is the highest one. So 2 is bigger than 0, so the degree for this binomial is 2. This one will also be 2. Now, they have different variables, but that doesn't matter. The concern is just what's the biggest exponent. It doesn't matter if it's on the same variable or a different variable. This has a 2. This has an understood 1. 2 is bigger than 1, so its degree is 2. Now, this for trinomial, I use this example on purpose. This isn't something that's unique to trinomials. This could happen with binomials. Anything with more than one term, this could happen. So most often, the biggest exponent will be first. But that's not a requirement. You can't assume, oh, that's the first term, it'll have the biggest exponent. As you see, we have an exponent of 2, then an even bigger one, 4, then an even bigger one, 10. So the biggest exponent, the degree, is 10 because of that exponent right there. So don't stop by just looking at the first term and assuming that's all you have to look at. So this last block is not talking about degrees. It's just helping you remember what the definition of polynomial is. So if you look, there were two things that say it's a polynomial unless there's a variable in the denominator. So it's this that makes us say, no, not a polynomial. Or if there's a variable in the exponent. So it's this that tells us, nope, that's not a polynomial. Okay, so on this next section, we're just saying, is it a polynomial? If it is, we want to say if it's a monomial, a binomial, or a trinomial. That's just telling us how many terms there are. And for all of them, we'll find the degree if it's a polynomial. Now, if it's not a polynomial, we just say no and we move along. So if you want to pause and try this on your own, feel free. But if you just want to watch, that's okay too. Okay, so this, as far as is it a polynomial? Well, the two no-nos are a variable in the denominator or a variable in the exponent. Well, this has neither a denominator nor an exponent. So that means there can't be a problem. So yes, it is a polynomial. Since there's just one term, it's a monomial, one mono. And the power is 0, because this is a constant. There's no exponent whatsoever, so we say the degree is 0. Okay, now this one we consider the no-nos. We cannot have a variable in the denominator or in the exponent. There's a variable in the denominator. So this one is not a polynomial, so we don't have to answer any of the other questions because they don't apply. Okay, number 3, we look for the no-nos. Does it have a variable in the denominator? Nope, there is no denominator. How about the exponent? Nope, there is no exponent. So that means that this is a polynomial. And there's 1, 2, 3 terms. 3 terms means it's a trinomial. In the degree, well, these both have an understood 1. Now we don't do 1 plus 1. We're just looking for the highest exponent. It may appear more than one time like it does here, but the degree would be 1 because that's the highest exponent we see. Now, I want to briefly say, you might be looking at this and saying, well, wait a minute, we could combine 7x minus x and make it 6x. You're of course right. So it is possible on this one in particular to simplify it so that it become a binomial. But since we were just asked to identify what we're seeing, all we have to do is say, okay, well, that's 1, 2, 3 terms. So in its current state, it is a trinomial. Okay, number 4, are there any variables in the denominator? Nope, no denominator. How about the exponent? Well, there is an exponent, but that's not a variable, so that's okay. So yes, it's a polynomial, and it has 1, 2, 3 terms, so it's a trinomial. And the biggest exponent we see is 2. There's 2, there's the understood 1, and this is a 0. So 2 is the biggest exponent, so the degree is 2. So this is a trinomial of the second degree. Okay, number 5, we see a no-no. There's a variable in the denominator, so we have to say, sorry, you are not a polynomial. Because we cannot have a variable in the denominator and be a polynomial. Okay, last one in this section, 6x plus x squared. There's none of the no-nos, no denominator where a variable is showing up. And we do have an exponent, but it's a number, not a variable, so we're okay. So yes, it's a polynomial. There's 1, 2 terms, so it's a binomial. And the biggest exponent I see is the 2, so the degree is 2. Okay, next section. Write each polynomial in standard form. So standard form means you write the term with the biggest exponent first, and then you just go down from there. Also, it says identify the leading coefficient. Now, the leading coefficient is sometimes abbreviated LC, capital L, capital C, and it's the coefficient in front of the term with the biggest exponent. And this is really important because lots of people want to make the leading coefficient the biggest coefficient. The size of the coefficient is not the issue here. It's which coefficient is paired with the biggest exponent. So it's still the size of the exponent compared to the others we're concerned with, not the size of the coefficient. So first step, as we look at number 1, we want to put this in standard form, which means you look for the biggest exponent. That's right there, that's the 5. We write that term first. So 5 is the biggest exponent. Next would be 3. And last would be x squared. So 5, 3, 2, 5, 3, 2. We went from biggest to smallest exponent. Now, the leading coefficient is the coefficient in front of the biggest exponent. Well, the biggest exponent is 5. And this is why they call it the leading coefficient, because when we put it in standard form, the biggest exponent is going to be in front. It's going to lead the pack. So the leading coefficient is 1 because there's an understood 1 in front of this x to the 5th. Okay, number 2, looking for the biggest exponent. Okay, that would be 5. Now this negative stays with it, so I write negative 7 x to the 5th. Then I looked for the next smallest exponent, that's x to the 4th, so plus x to the 4th. The next smaller one after that is 4x cubed. And the constant is last, plus 1. So that's in standard form because we go from biggest, 5, down to smallest, 0. And the leading coefficient is the coefficient in front of the biggest exponent. The biggest exponent is 5. The coefficient in front of that variable is negative 7. So the leading coefficient is negative 7. So I would encourage you to pause this and try and see if you can do the next 4 on your own. Once you're ready, hit play and you'll see me run through it. So on number 3, the standard form, we got to put the biggest exponent first. So the power of 8, that's the biggest exponent. 6 comes next, and that's a negative 3, so minus 3x squared. 5 comes last, that's minus x to the 5th. So that's standard form. Now the leading coefficient is the coefficient that's with the variable that has the biggest exponent. The biggest exponent is 8. Its coefficient is 2. Okay, on this one, the biggest exponent is 8, so we put negative x to the 8th first. Then we put plus 2x to the 7th. So that is placing the exponents in order from greatest to least. And then the coefficient in front of the biggest exponent is actually a negative 1. So the leading coefficient is negative 1. Okay, on number 5, we want to do the standard form. So we look for the biggest exponent. That's right here. It's the 5x to the 4th term. That's the biggest exponent. X squared is the next, so minus x squared. So notice how whatever term is right in front of it, I keep it with it. So that was a positive x to the 4th, I kept it positive. A minus x squared, I kept it minus x squared. We have a positive 3x, so I'll say plus 3x. Then a minus 2, so I'll say minus 2. Then the leading coefficient is the 5, because it's the coefficient paired with the biggest exponent. Okay, number 6. 5 is the biggest exponent, so we have negative 4x to the 5th that goes first. Negative 2x to the 4th goes second. This is next to the first, so that would go third. And then the 3, the constant that has no variable, would go last. So that is standard form. And the leading coefficient is the negative 4 because it's the one paired with the biggest exponent. Okay, let's flip to the back. Now, we're going to be simplifying or combining like terms here. And just a reminder, to be like terms, they have to have two things: the same variable and the same exponent. So like, I can't add a y and an x together because they have different variables. But I also can't add an x squared and an x together because even though they both have x's, this has a variable of 2, this has a variable of 1. So we've got to look for like terms. So I see a term with an a here. I also see a term with an a here. So I can say 4a plus 3a is 7a. I've covered those two. You don't have to cross them out, but if it helps you know what you've taken care of already, you can. And then these are also like terms because they're constants. Negative 5 plus 6 is plus 1. Okay, it's also best to go with the biggest exponent first. So in 14, the biggest exponent I see is x squared. And there's no other term here with x squared, so I cannot combine that with anything. I just write 4x squared. We do have a term with an x, 6x, but there's no other term here with an x, so I just have to leave that as it is. However, we do have two constants. So 9 plus negative 7 is positive 2, because it's really 9 minus 7, so that's 2. Okay, now it's a little hard to tell what order you supposedly should put them in when it's like this, 15, where they're mixing up variables. So I won't be as picky about the order on ones like these. But just telling you what I would do. In this one, I'd say, all right, this is more complicated, just like squared is more complicated than just x. So the xy is more complicated, and I do have two of those. 6xy plus 4xy gives me 10xy. So they can be combined because they both have an x and a y. So those two are covered. Then I tend to go alphabetical. Again, I won't be picky as long as you have the right terms. But I just think, okay, I'm going to do x next because it's alphabetically before y. So we have 6x minus x, which is 5x. And that just leaves the 2y, which will stay just as it is. (16) x squared plus negative x squared. So that's 1x squared plus negative 1x squared. 1 plus negative 1 is 0, so these two actually cancel each other out. Then we have 1y squared plus 1y squared, which is 2y squared. Okay, 17, it's all p's, but let's start with the biggest exponent and go down to the smallest. So I have 3p squared plus p squared. So 3 plus 1 is 4. Then I have a negative 2p plus negative 7p. So negative 2 minus 7 is negative 9. Then I have the constants, 3 plus 7, which is 10. On 18, I like the order they have it in this first term, because in some ways these are all equally complicated because it's two variables in the sense that it's x times x times y, and y times y. But this way it's kind of alphabetical. But again, I won't be picky when we've got mixed up variables about the order you put stuff in. But I see first, oh actually I take it back. Well, I'm going to go the other way. X squared. Oh, there's another x squared term. 2x squared minus 6x squared is negative 4x squared. So that covers those two. Okay, 5xy. Oh, well, we don't have any other xy terms, I don't believe. Oh, we do. Wow, I can't even see very well. Plus 5xy minus 1xy. So those two can be combined. 5 minus 1 is 4. And then this is the only term with y squared. So I'll say plus 4y squared. Now this is the only term with 2y cubed, so I'll just say plus 2y cubed. Okay, on 19, again, it's just one variable. It's all, oh, no, it's P's and R's, excuse me. So P comes first in the alphabet, so I'll deal with that first. And the biggest exponent I see of P is right here. Now you have to be careful. In 13 through 18, it was all adding the two things together. But now, for the rest of them, we're subtracting. So you got to remember, this is minus negative 6p squared. So minus a negative turns into a positive 6p squared. Now here's one of the single p. There's no other p's here, so we just leave 8p as it is. We have negative 5r minus 6r. So got to make sure you remember that minus. Negative 5r minus 6r is negative 11r. Then it's minus negative 3, so minus a negative turns into plus a positive 3. Now you don't have to do this, but one thing you could do if it helps you with your signs, I'll just rewrite this first one just as it is, no changes, and say, okay, minus negative 2x, that's plus 2x, minus negative x squared, that's plus x squared, minus 5, that's minus 5. So if you want to write it out that way so you don't have to remember the minus as you're combining like terms, you can. But I'll leave that up to you. It's cool if you do, but if you're able to do it without, that's also fine. So this is all x's, so look at the biggest exponent. So we have 2x squareds, or two terms with x squared, I should say. 8x squared plus 1x squared is 9x squared. We have two terms with single x's. Negative 4x plus 2x is negative 2x. Negative 3 minus 5 is negative 8. Okay, 21. We're all x's, so we'll start with the biggest exponent, which is x squared. 3x squared minus 3x squared is 0, so the x squareds just cancel out. Negative 2x minus 5x is negative 7x. And then we have a minus out here and a negative here. Minus a negative turns into plus a positive, so we get plus 1. Okay, just to help us, since there's lots of terms here, I'm going to rewrite this one by going ahead and kind of applying that minus to all the things. Minus negative x squared is plus x squared. Minus 2xy. Minus negative 5y squared, so it's plus 5y squared. So that takes another bit of effort to write that line, but on the plus side now, you have less areas to make mistakes because you're unlikely to forget, because you don't have to forget the minus because it's already been applied. So we'll start with x squared. I see a term here, 4x squared plus x squared, so 4 plus 1 is 5. Then I have a 6xy minus 2xy. 6 minus 2 is 4. Last we have y squared. 2y squared plus 5y squared is 7y squared. Okay, last two. So this one has xy squared. So let's look. Anything else have xy squared? No, that has x and y, but no squared. That has x and y, but no... Oh, wait, there it is. 9xy squared minus 8xy squared. 9 minus 8 is 1, so we have 1xy squared. And you don't have to write that 1. You can just leave it as it is. Oh, except I just made the mistake I warned you guys about making. I didn't do it on purpose either. So it's not 9 minus 8. It's 9 minus negative 8. So that really becomes a plus. Because 9 minus a negative is the same as plus a positive. So it's 9 plus 8, which is 17 xy squared. Then we have 5xy minus negative 2x. So it's really 5 plus 2, giving us 7xy. So I'm going to go ahead and distribute this one through the minus sign so I don't repeat my mistake. So minus a negative is plus, minus a negative is plus, minus that negative is also plus. So this turns them all in this side to positives. So we'll go alphabetical. They have an H, a J, and a K. So I'll do H's first. 2H plus 7H is 9H. Negative 6J plus 5J is negative 1J. Negative 2K plus 4K is plus 2K. So that completes our study of polynomials. Make sure you understand what makes it a polynomial and what doesn't, the degree, the leading coefficient, standard form, and how to combine like terms.